we'll spend a little bit of time talking about the parabola. We have encountered parabolas before, or you have, whether you did it with me or with somebody else. If you looked at or studied quadratic equations, if you graph a quadratic function, it always has the shape of what we call a parabola. We're going to look at a more broader definition of a parabola. It does boil down to a quadratic of some kind, but geometrically its definition of this curve is that it's a set of points. And what makes something a point on the parabola, you got to do two things first. You're going to fix a point, which we call a focus, and then you're going to draw a line. Now, neither this fixed point nor the line are actually on the parabola, but they're going to define it for us. What makes something a point on the parabola is that its distance to that point is the same as the distance to the line. And that is the geometric definition of what a parabola is. So that line that we draw is called the directrix. That fixed point is called the focus. There's a point halfway in between the directrix and the focus called the vertex. That's the nose that's on the parabola. And then each parabola has symmetry, and the line of symmetry, or its axis of symmetry, is the line that goes through both the vertex and the focus. So in this definition, here's the focus in this case at P0, and the directrix is this vertical line. We are going to work first with parabolas that have their vertex at the origin. And here's a parabola that is oriented horizontally. We'll also look at parabolas that are oriented vertically. But if the vertex is at the origin, knowing that that vertex is going to be the same distance to the focus as it is to the directrix, that means that if the focus is, say, over here at the point P0, then the directrix has to be the same distance the other way. And so that vertical line has the equation x equals negative p. So there's one point that's easy, right? Equidistant from this line as that point. Now, what about all the other points? So in this figure, we picked this point we're calling p. It's an arbitrarily chosen point. That's why we're just giving it coordinates x, y. What we know about it is that it's on the curve. It's on the parabola. So what that means is that if I take its distance to the focus, it'll be the same as its distance to the directrix. And I'm going to be really clear here. When we talk about a distance from a point to a line, we always mean the shortest distance, which is a perpendicular distance. Because I could draw that's a different distance, and that's a different distance, and that's a different distance. But we always mean the shortest distance, so that's the perpendicular distance. And that distance is really easy to find because it's just a horizontal line here. So right x minus left x is x minus a negative p, so that distance here is p plus x. I'm going to stop there for a second and see if we're okay with that. The other distance is not so bad because it's just, we know we have a distance formula, right? So if we just use the distance formula on the points x, y, and p0, you get this expression, right, with the radical. And what makes that a point on the curve is that those distances are equal. So using the geometric definition of the parabola, we know that x plus p is equal to the square root of x minus p squared plus y minus 0 squared. Certainly, that's an equation that represents that curve. It's just not very nice. So we're going to rearrange this. I'm going to square both sides. Get rid of that radical. On the left side, I'll multiply that out. So we get x squared plus 2px plus p squared. On the other side, I've got x minus p squared plus y minus 0 squared. We squared that radical. And now we can multiply out the stuff on the other side. Doesn't look any better right now. But I'm going to isolate that y squared. So on the right side, I'm just going to subtract the x squared, add 2px, and subtract p squared from both sides. What do we get on the left side? Mm-hmm. And this is equal to y squared. So here's the standard form for the equation of a parabola that's oriented horizontally, whose vertex is at the origin. In this equation, P represented the x-coordinate of the focus. So the vertex is at the origin. If it opened this way, P would be negative, right? And so this, whatever that ended up being, would be like a negative something x equals y squared. More broadly, and we'll look at this when we look at parabolas whose vertices are elsewhere, P will always represent the distance between the vertex and the focus, the directed distance, right? So it'll still, like whether or not this is positive or negative will tell us if it opens like to the right or to the left. But it may not always represent, P may not always represent the coordinate if the vertex were located elsewhere.
And y squared means it's oriented.
Yeah, right. Y squared, the fact that it's a y squared and not an x squared means that it's oriented like horizontally. And in fact, when I'm just looking at the equation, I can tell it's a parabola because one variable is squared and one is not. So let's see what we could do with this. We're working with the equation y squared equals 12x. Definitely a parabola, oriented horizontally. Vertex is at the origin. I'd be able to tell the vertex were somewhere other than the origin because there might be a constant term, or maybe there'd be a plain old y term or something like that. But if it's just y squared equals some coefficient times x, then it's vertex is at the origin, opening horizontally. Or if it was x squared times some coefficient on y, then it's still vertex at the origin, but just oriented vertically. So we're working with y squared equals 12x. So that means that here, if I look at this coefficient, this is 4p. Right, which means that p is equal to 3. It's a positive 12x, so that means it's going to open to the right. What do we think the coordinates of the focus should be? So say that again?
Oh, I was talking, I meant the Directrix.
Oh, yeah, right. Okay, I see what you mean. Yeah, the focus will be a positive 3, 0. Because if the vertex is at the origin, then P really does give you the x-coordinate of the focus if it's oriented horizontally. And what's the directrix? Yeah. And it's an equation, it's a line, so we should probably write it as an equation, so like x equals negative 3. And then when we sketch it out, I'm being pretty rough right now, but like, I know it opens to the right. I could easily, if I wanted to make my sketch a bit more accurate, it's maybe not a bad idea, but I could easily just plug in, x equals 1 and see what the y values are, and that'll just give me like another point to kind of anchor it down. Notice that a parabola always kind of swallows the focus. It opens away from the directrix. The language we use, we know that this is oriented horizontally because the y is squared. We say it opens about the non-squared variable. So it's the non-squared variable here is x, so it opens about the x-axis.
How did you get 4p equals
4? Because the standard form, the one that we kind of derived this ourselves when we were working with that equation, is y squared equals 4px. So I just took that coefficient and said, well, that 12 has got to be my 4p in this case.
Okay.
Joe, did you have a question?
Yeah, so that doesn't really tell you like how acute the parabola is though, right? It's just kind of a...
Oh, you can plug in for another point, right?
Yeah, I mean, so depending on what that coefficient, depending on what p is, like if I kind of pull the focus out further or push it closer to vertex,
Yeah.
it'll kind of open wider or narrower.
Okay.
And we can kind of get a sense for that. You know, if I plug in x equals 1, then we get y squared equals, you know what I'm going to do? Hold on. I'm going to do, just because it makes the arithmetic easier, if x is 3, then we get y squared is 36. So that, in fact, this probably opens pretty wide then. Let me try, let me oh, that's kind of off. There we go. That's slightly better. Other questions? Okay. Let's do another. Y squared equals negative 8x. What do you think, what are some observations or things that you think we would observe about this parabola? Can you say that with words? Opens to the left. What makes you say that? It's a negative. And we know it's still oriented horizontally because what? Y is squared, yeah. So we have y squared equals negative 8x. That means that... Yeah, so 4p is negative 8, which means p is negative 2. So that means, yeah, the focus has coordinates negative 2, 0. What about the directrix? Yeah, what is 2?
Oh, x equals.
Yeah, good. It's the equation of a line, so. And we always draw the directrix dotted, or I think we should. I always draw it dotted. It's not a part of the curve, it just defines it. Opens to the left end. We can get another point to kind of anchor it down. If I were to plug in negative 2, that gives us y squared equals 16.
So y equals 4.
Yeah. Questions so far? Okay. A parabola that opens upward or downward, is oriented vertically. The equation is just the same. You kind of just like swap the roles of x and y. So it's x squared equals 4py instead of y squared equals 4px. So I can tell which way it's oriented based on which variable is squared. P still takes on the same meaning when the vertex is at the origin. It's still distance from the vertex. It still gives you a coordinate of the focus here. But because it's oriented vertically, it's the y coordinate of the focus, right? And the x coordinate will be 0. So if I've got the parabola, x squared equals 4y. That opens vertically. Does it open up or down? Up, yep. So 4p is equal to 4. That means p is 1, meaning positive 1. So the focus is 0, 1. And then y equals -1 is the directrix, yeah. If I wanted to get a slightly more accurate graph, I could plug in this case I'll plug in a y coordinate and get a couple x coordinates. So if y is equal to 1, then we get x squared is equal to 4, and that means x is plus or minus 2. One more example here. 2x squared equals -9y. What do we notice about this? Well, divide by 2. It's not quite in the standard form yet. So now what do we know about this parabola?
It opens above the y.
It opens about the y, and is it up or down?
Be positive.
What's that?
Positive.
What's positive?
And it up.
Well, let's see. This one opened up. So what's p in this case? Why down?
Oh, it's
Right, like so this coefficient itself is negative, right? So if we go from that, right, 4p is -9/2, and that means that if we divide by 4 or multiply by 1/4, p is in fact -9/8. So our focus, yeah.
If we really wanted to, could we put it in decimal form?
If you really wanted to,
Yeah.
like how bad do you want to?
Like, pretty bad.
Really?
Because sometimes there's like, it's a hassle to transfer it.
That's just over -1.
Yeah, like just a little bit more. We're going to sketch it. It's a little bit more than -1. I mean, like it's kind of a moot question because I'm sure you don't want it that bad, right? Like you don't
I
like.
was just asking.
You're just asking because.
Like if I'm on a test and I just
Yeah.
forget to transfer it in the fraction.
I mean, if you you know, it's funny that you say transfer it to fraction because I feel like it's already in a fraction form. But like, if you were like, let's say when you divided by 2, right, and you decided as you divided by 2, you just wrote that as -4.5,
Yeah.
and then you divide by 4. I mean, like that's okay.
Yeah,
Yeah.
that's what I meant.
That's okay. Yeah. So there's our focus. What's our directrix? What's positive 9/8? Y equals. Because it's a line, right? We want to remember that. So a little bit beyond 1. Whoops. And then it opens downward. Okay. So that's fun. If you know, vertex at the origin, we kind of know how it works. We know if it's in standard form, we kind of know how to pick out what the focus and the directrix are and how it should look. So we're going to do an example now where the vertex is not at the origin. We're going to do it by using the definition of the parabola. By definition, we mean that part in the beginning where we talked about how what makes something a point on the parabola is that that point will have the same distance to the focus as it does to the directrix. In this case, they're saying they're giving us the focus and the directrix. I mean, geometrically, a parabola is defined by those two things, and if I know what they are, I should be able to get the equation. So that's what we're going to do here. The first thing I'm going to do, I think, is just because, you know, when I'm given a problem where they start out just by giving me geometric information, I kind of flail about a little bit. Since I have all that time while I'm flailing, I might as well plot what they give me. So there's the focus. And the directrix is y equals -1. Which way do we think this opens? Up. Yeah, it's certainly oriented vertically because it's got a horizontal directrix. And it opens upward because, you know, the vertex has to be in between these two, right? So the vertex is somewhere here, and it has to kind of open away from the directrix and swallow up the focus. So we know it opens vertically. Do we know what the vertex is?
Yeah, it's the equal distance,
Mm-hmm.
equal distance between the focus and the...
Right, so this distance here is 3 plus 1 is 4. So I'm going to go halfway down. So if I go 2 down, that's 2, 1. And I'm doing this just because what I want to sketch it first. Like, and so I haven't found the equation, which means, you know, maybe, I don't know how accurate that is. Maybe it opens wider or less wide. But the reason I'm doing this is because for me, I get kind of visual, and I know that this is based on distances. So I just want to be able to draw those distances and like kind of make it concrete in my mind. So I'm going to pick a point, arbitrary, on the curve. Call that xy. So I know that this distance is going to be the same as that distance. And again, maybe it's not the most accurate graph because I know those distances don't look the same, but mathematically they're the same, okay? Magic. What is, yeah?
How did you get the vertex there?
Oh, the vertex, so the vertex is on the parabola, right? Which means it's the same distance from the focus as it is to the directrix. So if I consider like this line that goes to the focus down to the vertex, it's got to be halfway through. Now I don't need to know the vertex in order to do what I'm going to do. I just wanted to plot it. I just wanted to sketch the parabola. If I sketched it and said I think the vertex is somewhere around here, and still drew it so I could draw my distances there, like everything we're about to do doesn't require us to know that the vertex is 2, 1. What is that vertical distance? Like,
Does that drop down to the directrix? Or?
yes, to the directrix. Like, so it's not going to be a number, right? In terms of, so that point is like an arbitrarily chosen point, x, y. So that's a vertical distance. How do we get a vertical distance?
The bottom point up.
Yeah, so top y minus bottom y. The top y is just y. And then we're going to subtract the bottom y, which is -1. So y plus 1. There's that distance. The other distance, we'll just use the distance formula. And then we're going to set those distances equal. So y plus 1 is equal to, and now what does this look like if we just plug in the distance formula? You don't need to simplify or anything, but just how does it go?
-2 minus x1 squared.
Yep. So that would be x minus 2 squared, right?
Plus y2 minus 3
Yep.
squared.
So this equation absolutely represents that parabola. Maybe we can make it look a little bit nicer. Well, we can do the same thing we did when we were kind of deriving that equation in the beginning. Yeah, we'll square both sides. So y squared plus 2y plus 1. Over here, we're squaring that square root, so those go away. Is everybody okay if I just also, at the same time, FOIL out those squares? So we get x squared minus 4x plus 4 plus y squared minus 6y plus 9. Doesn't look much better. But the y squareds are going to drop out. I got a single y squared on both sides. And maybe we could just solve this for y, get a y equals. I mean, it's obviously a function, like y is a function of x, so we could get it in that y equals form. Let's subtract y squared. And maybe I'll get all the x's on the right and all the y's on the left. So I'll add 6y. And then I'll subtract 1. I'll get the constants on the other side too. So on the left side we have 8y. And then we have x squared minus 4x is 13, minus 1 is plus 12. And then we just divide by 8 or multiply by 1/8. And I'll leave it like that. So, this form that we have it in, this equation, so we found an equation, roughly simplified, I guess. I would say that this is nice if we wanted to plug it into a calculator to have an explicit function form, that some of the TI-84 can handle nicely. But it doesn't have that same satisfying quality. That when we were doing the circle and we could just get it in that standard form and then boom, we know exactly where it is. Like if I just saw this equation without any additional information given about it, I could tell it's a parabola opening upward because it's the x squared and not the y squared, and it's a positive x squared. So I know it opens upward. I would have to be required to do some work to get the vertex, maybe to figure out the focus or directrix. So what we want is like a standard form. And so there is a standard form for the equation of a parabola that is remarkably similar to the standard form for the parabola whose vertex is at the origin. I mean, this y minus k squared is 4p times x minus h. It is exactly like y squared equals 4px. It's just that we're replacing y with y minus k and x with x minus h. And we do that this is the equation for that parabola if it opens horizontally, and the vertex is hk. So with the circle, h and k were like the coordinates of the center, and with a parabola, they're the coordinates of the vertex. And so it's similar, right? So the basic form of the equation is precisely the same. We just make an adjustment depending on where the vertex is. And note that if the vertex is 0, 0, these equations reduce to the ones we've already worked with, right? If h and k are both 0. So let's find the equation of a parabola with vertex 2, 4 and focus 4, 4. So look, they're starting out. They're giving us geometric information. What's a way that we could start this out? Sketch it. Let's just plot these points and get an idea. Because one of the first things we need to do is figure out which one of those two equation forms we're going to use. Like we need to figure out which way we think it opens. So vertex 2, 4 and focus 4, 4. Opens to the right. It's got to, right? A vertex, or a parabola kind of swallows up the focus, and neither of those points looks like it's actually drawn where they belong. Slightly better. Okay. So we know it does something like this. I mean, they didn't ask us to sketch it, but, you know, whatever. So it opens to the right. So which one of these two equations do we use? Yeah, the y minus k. Well, they both say y minus k, but
The y squared.
y squared, yeah. So if it opens horizontally, we're going to use this form. And we need to fill in h and k and p, and they gave us h and k, right? That's just the coordinates of the vertex. So we know this is, so the vertex 2, 4 means h is equal to 2, k is equal to 4. So y minus 4 squared is equal to 4p x minus h. Now we just need to know what the value of p is. Where do we see the value of p?
Right there between, it's 2.
Because?
Because it's from the vortex to the focus.
Yeah, the p is always the directed distance from the vertex to the focus. So p will be a positive 2. So that gives us y minus 4 squared equals 8 times x minus 8. Whoops, I didn't fill in the 2 before. X minus 2. There's the equation. That's the standard form. That's the nicest form. They call, you know, we have like this sterile language in mathematics a lot of the time, like standard form, but like it's the nice form. Like we should feel like positive emotional association to saying something in the nice form. So we started with some geometric information. We're able to kind of leverage the standard form, the nice form, to make it easier on us to get the equation. But what if, you know what's coming next? Yes. Okay. What if they give it to us in not a nice form? What if they give it to us? Oh man, look at that. Look at how awful that is. What can I tell about this equation? It's a parabola. Yep. And because one variable is squared and one's not, which way does it open? Up or down, left or right? Yeah, up and down. Right. It's an x squared. I mean, and beyond that, I have to do work to figure it out. So the best way to do this work is to complete the square. Now, with a parabola, only one variable is squared, so you are only going to complete the square in the one variable. So that means in this case, I'm going to take the x squared, I'm going to group the x's with it. Anything that's not the x squared or the x, I'm going to throw over on the other side. So we'll add 9y and add 16. Now we like to complete the square on x squared, not on 2x squared or negative x squared. So let's go ahead and divide both sides by 2. Gonna leave some space. And then we have 9 halves y plus 8. What comes next?
Negative 1 squared.
Yeah, we're going to complete the square. What do we have on the left side there?
Y minus 1 squared.
Yeah, x minus 1 squared. Yep.
So it's
And then here we have 9/2 y plus 9. Now we have completed the square, right? We did complete the square. We're not quite done rearranging or rewriting this equation because it's not quite in standard form. On this side, what we want is 4p times y minus k, right? And so in order, the important part is not like, oh, what's 4p, right? Although that will become evident in a minute. The important part about that standard form is that on this part here, that on the right side, it's just plain old y minus k. Like they've factored out any coefficient on y. They've taken that out. So in parentheses, it's just y minus a constant. 1y minus a constant. So down here, what we're going to do is take that 9/2, and we're going to factor it out. So if I factor out the 9/2, definitely I know that's y, right? And then, what's next? What should the next term be? What? Let's check. If that is a 1/2, like if I check, then if I were to distribute this, I should recover the original. So, and that would be 9/4. So yeah, not a half. What do I multiply by 9/2 to get 9? 2. Yep. And one way you could do that is just take the 9 and then divide it by what you factor out, 9/2. So here's your standard form. What's its vertex?
1, -2.
Mm-hmm. We get the vertex here the same way we would get the center of a circle. After we've completed the square, after we've written it in standard form, that's the hard part, right? Like we've done all the hard work. Then we're just going to kind of reap the fruits of our labor. And then they also want the focus. Now, here it's going to be kind of important to think about which way it's oriented. So which way does this go? It's going up. Yep, so it's vertically oriented because it's x squared. It's going up because 4p is positive, which means p is positive. So 4p is 9/2, right? And so if I multiply by a quarter, we get p as a positive 9/8. And that is the distance. That's the directed distance from the vertex to the focus. So that means that the focus will be 9/8 units up, straight up from the vertex, because it opens upward. So that means that the x-coordinate of the focus has to be the same as the x-coordinate of the vertex. And the y-coordinate is, I'm going to take -2 and I'm going to add 9/8. So -2 is -16/8 plus 9/8, -16 plus 9, -7. And to make this visual, we still needed to know by looking at this, like it's important that we need to know that it opened upward. But like we could kind of visualize like how we get that focus in a very physical sense. I know where my vertex is, 1, -2, and then I'm just going up, 9/8 units from that. That's like really in a physical or visual sense, like that's what we're doing to find our focus.